Okay, here's your screencast solution for exam 1, problem number 7. In 7, we have this shock absorber system, and essentially I say in the problem statement that you can assume that equilibrium has been reached to establish the reference points x and y with respect to a certain reference level. Okay, and then RFT is supposed to represent the road, so you notice here there's definitely a bump in the road. Okay, so if our car hit that, it would cause this whole system to oscillate or react to that bump in the road. You know, that's the whole point of being a shock absorber system. All right, so what I was hoping to see from you on this problem was, first of all, a free body diagram for both the wheel and the car. Okay, so I put the wheel here, and we notice we have forces from the spring, that are connecting the wheel to the road, and the stretch on that spring would be proportional to the difference between x and r. Okay, so that was a real common mistake. Some people just put x, or some people just put r. Okay, so you would have the spring constant kW times the difference x minus r. Okay, so that was one of the most common mistakes. All right, the next common mistake is that the forces acting in the up direction on the wheel are proportional to the difference between y and x. Okay, so once you have this free body diagram, this equation is straightforward to write. Okay, now we have the same thing with the car. With the car, you just have the forces acting downward. Okay, and those, again, depend on the difference between x and y. All right, so once you have this free body diagram, this equation is straightforward to write. Okay, at this point, this is where people ran into problems. Okay, I think it's because maybe the problem was so easy you didn't expect it to be so easy. All right, so all you do to take the Laplace transform is everywhere you see a variable that has a derivative on it, you put an s times that variable. What I saw happen, and this was the major error, what I saw happen is people would ignore the reference signal, okay, assume it was 0, you can't do that, that's a major error, or you would just ignore any variables that you see and put down an s or an s squared. You can't do that either. So here we go. We have this equation up here, so that we have the, let me get a different color, pink, right? We have x double dot, and so s squared x, because that's an x, this is s squared x, okay? This is y double dot, so this would be s squared y, okay? Here's a ksy, ksy. So you get the idea. Every time you see the variable, you get the Laplace transform of that variable showing up in the equation. All right, and you can't forget the reference signal. That's also important. So that's all I needed. I didn't need you to simplify. This was the total answer here in the box for the Laplace transform of the system of